Welcome back to True North Mechatronics. In episode 1, we created the mobility base for our Sparkbot. Today, we're moving up the Z-axis to engineer the accessory deck. This deck will allow us to use the space between our gearboxes to create a structural manifold with a 27mm riser that serves as both a mounting location for our battery box, as well as providing a space directly above the gearboxes to mount a gyroscope. Design, engineer, deploy. Let's get to the CAD. Begin by creating a new body and a new sketch on the XY plane. We're going to use the polyline tool, and we're going to create a C-shaped profile around the X and Y axis. You can see here that these lines weren't horizontally constrained, so make sure that you go back and clean that up if yours weren't constrained. Let's create symmetry around the X-axis using the endpoints of these line segments, and we're going to set the vertical length of this C-shaped profile to 94mm. All right, we're going to create a symmetry up top here on the y-axis with this line segment. So let's create that symmetry there. And now we're going to use the polyline tool and create another C-shaped profile at the front of the deck. This is going to accommodate the ultrasonic sensor that we'll be adding to the front of the robot in a later video. So let's make that symmetric with respect to the x-axis, and let's set the length of this to 48.2mm. Now we need to set the length up here, so let's set that to 5mm. And we're going to close off the shape now. We'll constrain the location of this C in a minute, but let's use the Create Arc by Center tool. Begin by left-clicking on the x-axis, go out, left-click on that endpoint on that line segment, make sure you get right over top of it, put the crosshairs over top of the line segment on that inset feature there. We're going to do the same below. Resist the urge to left click on your starting point there. FreeCAD will give you an over constraint error. I'm sure that might be fixed in a later version of the software. Make sure that you are seeing those red coincident constraint markers, otherwise you'll get a wire not closed error later when we try to pad this out. All right, let's set the distance to the edge of the deck now. And we're going to set that to 61.2mm. All right, next we need to constrain the radius of these arcs that we created. So let's set that to 302mm. That was the value that we used when we were creating the accessory deck in episode 1. So we're matching that profile. Now before we leave this sketch, we're going to create two pockets. These pockets are going to be used to accommodate infrared obstacle detection sensors. Now these IR sensors are useful because they can also be used as line following sensors. They are convenient for detecting transition between black and white colors. So that's how we're going to use them. And we're going to set the length of this slot to 11.5mm, and we'll also set the width of these slots to 6mm. All right, I'm going to zoom in here so that we can see these constraints a little bit easier. So there we are. Now let's set the distance between these two pockets to 27.5mm. And now we want to set the location. So where in the deck are these going to sit? Now it might be useful to reference the y-axis, but we're going to reference the front of the deck here. And we're going to create a 4mm offset from the front of the deck. And so at this point in time, all of our shapes are fully constrained. And we can close out of the Sketcher workbench now. So there we go. Let's close out. And we're going to pad this to 3mm. Now we're going to add a series of features and shapes to this to make it more complete. For right now, we are going to notice that we're looking at the bottom here. So let's rotate so that we're looking at the top of the deck. And on the top of the deck, so you can see here in the nav cube, we're looking at the top of the deck. Let's left click on that top face and let's create a sketch there. And now let's use our circle tool. We're going to create the mounting holes that will secure the battery box to the top of our deck. So let's do that. And we're going to make both of these so that they are symmetric with respect to the x-axis. And we need to set the diameters of all these holes so that they're equal to each other. And we're going to set the diameter to the minor diameter of the PT screws that we're using. So that minor diameter that we're choosing here is 2.8 millimeters. And now, because these will move as a group, we can now just focus on constraining these top holes. Let's reference the top edge of the deck, and we're going to constrain these holes with respect to this top vertex. So let's give it an offset from the edge of 5 millimeters and a vertical offset of 6 millimeters. So that fully constrains our left-hand hole. And for the right-hand hole, let's give it a vertical offset of 9 millimeters, and we'll give it a horizontal offset of 29 millimeters. All right, so now both of these holes are fully constrained. We can see that the bottom ones match the top ones, and we can close out of the Sketcher workbench. We're going to pocket these through the top of the platform, and the platform is 3 millimeters. The default length is 5, so that the pockets will clear. So let's accept that default value. All right, the next thing that we need to do is add the trunk of this T-profile. This is what's going to sit between the gearboxes and mount to the mobility base below. So let's reference the back edge of the deck, and using the rectangle tool, we're going to create a rectangle that we're going to make symmetric around the x-axis. So let's set the vertical length of that to 24 millimeters, and its horizontal length can be 60 millimeters. Now, this deliberately doesn't go all the way to the edge. This is where that ultrasonic sensor is going to sit, and so we need to leave a little bit of clearance space for the circuit board and the components on the circuit board at the back of that sensor. All right, so this is fully constrained and we can close out of it. Let's pocket this, or sorry, let's pad that out to 27 millimeters, and then we're going to create 2 mounting holes on the top of this. These holes are going to be coincident with the x-axis, and just like we set up in the mobility base, they are going to be at a distance of 40 millimeters from each other. Let's make sure that the diameter of both holes is equal, and we're going to set this to the minor diameter of the PT screw. The thing that we need to do now is we need to define the offset from the edge of the base, and we're going to set that to 10 millimeters. And with that, both holes are fully constrained and we can close out. And now we're going to pocket that to 12 millimeters. That just happens to be the length of the PT screws that we're using. Now we're going to rotate around to the back of the base, and we're going to left click on that back face. So make sure that that's the one that you're looking at. And we're going to create a slot here on this back face. Now I'm using 1.0.2 version of FreeCAD, and right now if I try to constrain this slot, I'm going to get an over constraint error. So to solve that, all you have to do is left click on the side of the slot and drag it out. The over constraint will be cleared by FreeCAD, just as long, of course, as you've got auto remove redundance turned on, and now you can constrain that slot. We're going to constrain the side of that to 6 millimeters, and we're going to constrain the radius of these arcs to 6.5 millimeters. Let's reference the top edge here, and we're going to position this slot so that it is 11 millimeters away from the mobility base. All right, so our part is fully constrained. We can close out of this, and we're going to pocket this right through at 60 millimeters and confirm that that went through. There we are. All right, so the next thing that we're going to do is we're going to add a feature to the top deck face, and this is going to allow us to pass the wires in from the ultrasonic sensor into the wire conduit that runs the length of the base here. So left click on the top of the accessory deck and create a sketch. All right, so now we're going to create a profile right here up at the front. It's going to be symmetric with respect to the x-axis. So grab that polyline tool and create a shape that looks something like this, making sure that you are watching for those horizontal and vertical constraints. So I missed one here and I missed one there. So those are now constrained. Oh, I also missed that one there. Let's set the front edge here so that it's symmetric with respect to the x-axis, and let's also set this inside edge so that it's symmetric. And now we can constrain our vertical lengths. Let's set this one to 11 millimeters and this one here to 5 millimeters. All right, so now that we've got those constrained, let's constrain the horizontal line segments. So let's set this one to 4.5 millimeters and the last one to 4.8 millimeters. So our shape is fully constrained now, and we can pocket this through the deck. That's going to require a full measure of 10 millimeters to clear all the way through into the wire conduit. And so the next thing that we're going to do is we're going to add some support bosses here at the side of our accessory deck. So left click on that front face, and we're going to create a sketch. Now when we do that, the bottom edge of the deck is still visible. So we're going to use the view section tool, and we're going to push that back so that we're looking at just the edge of our stanchion here. Let's reference the top and inside edges there, and using the polyline tool, we're going to create a vertical line segment. We're going to come over about 8 millimeters down to the bottom edge here and close that off. So this bottom edge is going to be set to 3 millimeters. Make sure that you've got that vertical constraint there, otherwise this is not going to work properly for you. And we're going to set that inside edge to 8 millimeters. And let's set this to a distance of 10.5 millimeters from the front edge of the stanchion here. All right, so we're going to pad this shape out to 14 millimeters, and we're going to repeat this process on the other side of the accessory deck face here. So again, referencing those edges, and make sure that your line is vertical so that you don't have problems mounting that infrared sensor later. So there's a 3 millimeter and an 8 millimeter. Move those out so you can see them, and bring that into 10.5 millimeters. And then we can pad that out to 14 millimeters. Okay, so both of them are looking the same. We now need to add the mounting holes for our sensors here. So left click on the front face of one of those bosses. And because we have the y-axis that we can use here as a line of symmetry, we're going to create 2 holes, and we're going to make them symmetric with respect to the y-axis. And both diameters of these holes are going to be equal and set to the minor diameter of our PT screw. And let's take and create a distance from center to center of both of these. We'll set that to 38 millimeters, and we're going to reference the bottom edge of this boss that we created, and let's set the distance there to 7 millimeters. Okay, so 7 millimeter offset. There's our fully constrained set of holes. We're going to close this now, and we're going to pocket those through. That should be 8 millimeters to clear all the way through. So yes, we can see that we cleared all the way through. And the last thing that we're going to do now is we are just going to reduce the amount of plastic that this part requires by chopping a hole in the back here. This is just wasted plastic at the back. So let's left click on that face, create a new sketch. And we're going to create a circle approximately right there. Let's set the diameter of it to 18 millimeters, and let's reference the back edge of our accessory deck. Let's give it an offset of 21 millimeters, And let's set the distance of the center of the circle to the bottom of the deck. Let's set that at 14 millimeters. So that shape is fully constrained, so let's pocket it all the way through. 25 millimeters, there we are, it clears all the way through. When we're 3D printing, the top part of the arc will support the creation of this, so there's only a minor bridge for the nozzle to have to complete as it's printing. It's going to be printed on its front face like this, so the 3D printer will be capable of doing that. All right, so at this point in time, our accessory deck is locked in. We've successfully reclaimed the dead space between our gearboxes, and we've created a conduit for the wires to come from the ultrasonic sensor. And the platform is also providing a mounting location for the gyroscope that will be directly above the axles on the gearboxes. In the next video, we are going to engineer the pedestal mount. For autonomous navigation, we have to track our wheel odometry, so we're going to design a secure mount for our IR tachometers, and this will lay the groundwork in this robot before we eventually upgrade to Hall effect quadrature encoders in version 3 of this robot. This pedestal will also act as the critical anchor point for the vertical frame rails that support the overhanging weight of the battery box. So, chart your course, build your world, and I'll see you in the next one.